I'm also pleased to introduce Dr. Quentarius Moore as our second 2024 Frederick House Scholar in Computational Science. Quentarius completed his PhD in chemistry in 2023 at Texas A&M, where he was advised by Professor James Batias. Following graduation, Quentarius joined the High Performance Computing Applications team at Advanced Micro Devices, AMD, where he is presently a member of technical staff. Quentarius has been selected as a House Scholar due to his outstanding research achievements and his demonstrated leadership and character. Quentarius has substantially advanced our understanding of how mechanical distortions affect the chemical reactivity of two-dimensional materials, for example, graphene. This field, mechanochemistry, promises substantial societal impacts, including low-cost, environmentally friendly chemical synthesis. His research stands out for its close collaboration with experimental scientists. For instance, by developing ways to use density functional theory in the context of graphene under strain, he revealed how even small strains can dramatically alter chemical reactivity. His computational contributions enabled the first direct comparisons to experiments and the development of new experimental methods. During 2 summer practicums at Sandia National Laboratories, he studied strain effects on single-layer molybdenum sulfide deposited on gold surfaces, yielding a paper in ACS Nano. Quentarius also completed an internship with the HPC applications team at AMD, where he was assigned what his mentor describes as, and I like this, quote, a Hail Mary effort to port the quantum chemistry code Quantum Espresso to AMD's graphics processing units, GPUs. After achieving this Herculean task during his internship, he also optimized this code for the newest AMD GPUs on the Oak Ridge Frontier supercomputer, yielding long-lasting impacts on other AMD HPC efforts. Quentarius also demonstrated leadership and character throughout graduate school. He served as a leader for outreach and community engagement in the local chapter of the National Organization for the Professional Advancement of Black Chemists and Chemical Engineers. When the National Science Foundation awarded Texas A&M the Center for the Mechanical Control of Chemistry, Quentarius led a major outreach effort by initiating the center's YouTube channel, creating a global online seminar about mechanochemistry. Quentarius also recruited and trained other students to maintain continuity for these online outreach efforts. Among his peers, both in his advisors group and throughout the department, Quentarius developed a reputation as the go-to person for anyone who was facing difficulties and wanted advice. His contributions went far beyond service in professional settings. During his PhD, he volunteered at several nonprofits around the Texas A&M campus, focusing on supporting the College Station community. In one of these, a K-12 after-school program, he organized a weekly chess program for students, serving at once as a teacher, a coach, a mentor, and a role model. Dr. Quentarius Moore has made substantial and varied contributions across his communities, demonstrating initiative and courage in addressing challenges. He exemplifies the kind of scientific excellence and leadership that Fred House encouraged in all young scientists. Let's recognize Quentarius Moore.
All right, I think it's still morning. Good morning, everyone. So today, I'm going to more so give you a story of just how the CSGF has enabled, my path, my journey, people I've come in contact with, and how everyone has just really been a light for me throughout this journey. And so I'll title it Enabling Excellence, Optimizing GPU Applications, AI Workloads, and Supporting the HPC Community. Because that's what we do in my team at AMD. But also I realize a lot of it is more than just speeding up code. We enable developers, we enable users, just like everyone here is enabled by what the CSGF stands for. So the agenda today, keep it nice and short. It's pretty much a storytelling today. So I really want to, once again, thank the CSGF for honoring me and giving me this award, and thank you all for coming out today and being able to see you, because I haven't been to a program review in 5 years. And so it's been a minute. And this is really one for me, every time I come to a program review, it's like getting away from the stresses of school, getting away from just trying to pass your program of study, and getting able to see all your old friends that you saw. Oh, so everybody knows about that part. So yeah, once you hit summertime, it's like, thank y'all, thank you. I get this. And so I'm going to go through a bit of what we've done at A&M as far as the scientific research, outreach, and what we do at AMD, and just conclude with some words to the audience. And so I don't know if Judy remembers this. This is back in 2017. Yeah. So my first program review, had a great time meeting everyone new, and of course Judy smiling. And after review, I just never be shy to the new fellows to hit up old fellows, people you see. I always stay in contact in some form or fashion. I know it gets tough, but people are always rooting for you. So emailing Judy, I'm sure everyone feels like this. I know I felt like this and all of my cohort members. She states here, I remember sitting through it my first year, wondering how in the heck I was accepted into the program. Funny enough, after talking to most of the other fellows in my fellowship year, it turns out that we were all thinking that, but were too afraid to say anything at the time. That rung so true for me. I'm sure it rung true for you all. But it's things like this which kept me going. People like Judy, people like Lisa, people like Lindsay, Michelle. It's just always nice to have that in your pocket, like people just rooting for you, even when you don't think no one's there. And so just a little bit about me. So I'm from Jackson, Mississippi. Went to Jackson State University in my hometown. And the funny thing is, during my program of study and my PhD, I ended up doing an internship with AMD. And the cool thing that I liked about it is that it was kind of a continuation of what I found in my home in CSGF and also my home in the Batiste group. Because I've been fortunate to always have lab mates that were a little weird, but in good ways. Like, they're always like excited to see you, even if you were having a down day, go to lunch, or we always did outreach. We always did summer camp with the Batiste group. And even at AMD, we did the Houston Food Bank, so we always did service. And even my mentor at AMD, we would play Rocket League after work, of course, but we would play Rocket League together. So I've always been fortunate enough to have these people come into my life who were just, I don't know, they're just always different. They saw something that you didn't see, and it made you just believe that you could do whatever you could do. And so here, I call my son Baxter. So even at AMD, I entered into like some photo forums just to do different things outside of our research every day. And then, still a little bit salty about this, but I entered into a chess tournament, did all right. But it's sometimes I realize with our research, you do have to just look at all the things that come with the research, not just the publications, not just accolades, but also it's always the people you meet because you always learn something new. And so here are my lovely lab mates. I've had plenty more, of course, because I was in school for 6 years. But here are my lab mates, and of course, if Dr. Batiste could raise his hand, it's my PI from grad school. Thanks for coming. And so through the CSGF, we did a lot of work. And I was fortunate enough to go through the program of study, which was always nice and fun, every year updating that. But we did a lot of great things to where Dr. Batiste and a bunch of his colleagues came up with the Center for the Mechanical Control of Chemistry, which we went through like 2 phases, and we did some of everything. Like just as Kyle was talking about, but Dr. Batiste has always been into looking at using surface chemistry to look at the different types of reactions on surfaces. But now with the center, we're looking more at using strain and mechanical force to drive these chemical reactions instead of just changing the properties of these materials, driving actual useful chemical reactions. And in this, as Judy mentioned, we did start a whole live stream. We did all types of outreach, and the collaboration became so big to where we were funded in phase 2, the $20 million grant award, which was always pretty cool. And then being able to go to Sandia, I don't know who's gone or who's going this summer, but Sandia National Labs was always pretty cool. I've never seen mountains, first time ever. So just always, I don't know, it's just always been cool to be in the CSGF. And so here's some of the work we did at A&M during my time there. As I've told you, we were awarded the NSF Center. And then through Nova Shade, we did a lot of different things. My favorite part, which is what I try to highlight here, is the chemistry open house. I don't know about you, but when you see 300 kids just excited about science, a lot of them are kind of, know-it-alls. They know everything. It's like, okay, that's cool. But then you have the ones who are clueless and cute, and they either don't care about the science or they really do and they're interested. So you just get this plethora of just students who come to Texas A&M and learn all day, and they have the chemistry roadshow. And this is literally my favorite thing about the Department of Chemistry at Texas A&M, this open house. And even during COVID, we did a live stream just to keep it going. And so now I just want to take you through a story of, what the CSGF and what my time at Texas A&M has kind of got me into the last, it's 10 months. I'm coming up on the anniversary at work. So I'm just going to go through just different projects I've worked on. And keep in mind, I'm a chemistry major. Even coming to the Petit's lab, he did chemistry I've never heard of in my life. So it was nice as a computational person, being side by side with experimental people and learning just things I've never even thought were possible. And so at AMD, I'm essentially a member of the technical staff, and we work more so on GPUs, which are graphic processing units. And so in this, we have a lot of different roles. You, of course, think off top, optimize the GPU applications, just make it go faster. But it's really more than just making applications go faster. As I've learned, and a lot of you may learn too, build recipes for these applications are usually non-existent or a little outdated. But of course, when we're working with these, essentially our new products or our next generation accelerators, this becomes a big task. And this is what was meant as far as the internship with Quantum Espresso, just how do we even get it to run? How do we deal with compilers? And as a chemist, I'm like, hey, this sounds cool, slow it down. But this is, for me, this is the fun part, getting things to work that don't work, haven't worked, and you're just trying to figure it out. And that's always the fun part. And then I've come across what's called requests for proposals, RFPs, and this is where everything really turns up at work. And it's kind of like a drop everything type scenario. But for me, I've been on a few RFPs to where last year I was defending with Dr. Petit, so they gave me some leeway. They said, hey, we won't bother you. But around December, things kind of turned up a little bit. And then we got into some work with Porg and optimizing these applications for HPC. And so what I've come to learn over the last few months of being at AMD is that what we're really trying to do is decrease the obstacles or better the functionality of these applications and enabling more high-performance applications on AMD hardware. And I've noticed that it's not really just about the build recipes. It's not really just about, hey, what are predictions or projections to new hardware, or even about porting and optimizing. It's really like the work that we do goes more towards the developers and the users. I used to be a user, and a lot of this is more so open source. And so with all three of these, I've come to realize every day or every week I have to ask myself after I do some work, who am I enabling? Have I recorded my work to where I can give this to the next person on my team? Can I give this to the next person at our hackathon with a national lab? And so a lot of this has to do with enabling everyone else and not just making things faster on our products. And so a few of the key hardware that I've worked on this year has been what we call our MI250X accelerator, which is what's in Frontier over at Oak Ridge. And then also our MI300A was what's called an APU. So instead of just being a single accelerator, you actually have a tightly coupled CPU and GPU on the same architecture. And this would be an El Capitan. And also, we take MI300X, which is just a solo GPU in itself. And so a lot of the work that we start doing is if we're running code on our current systems, but also we project to next generation architectures. And so this has been the fun part for me, because when you start, you have these goals, these aspirations, and I realized I thought too small because things really started turning up. So at first, it just started off with just a mentor-mentee experience where, hey, we're gonna put you on the RFP, we're gonna show you how to do profiling work. And so the first thing I touched was GROMACS. And traditionally, I've done DFT calculations with Gaussian and Quantum Espresso. So GROMACS, I was like, it's different, but I'm up for the challenge. And so it was pretty simple to where we just ran different benchmarks on our CPUs and GPUs. However, as things go on, you get a little ambitious, and I said, hey, I want to shadow someone doing work on AlphaFold. I like the AI space, learn a bit about it. And then, as I did my internship working with Quantum Espresso, this definitely popped back up. And so I really called it my old friend because Quantum Espresso, we have a love-hate relationship. Like, we get along after I do a few headlocks here and there, but with Quantum Espresso, it has taught me a lot about more so the computational space, because being in CSGF, you do get in your domain and you're using computational systems, you're using high-performance systems to do your work. And I've always told myself I want to be more than just a user. I want to be more than just a user. But I had no idea how you do that, because your research is dependent on your predictions of usually being a user. And so with Quantum Espresso, I've learned a lot about fortune compilers and why everyone at work calls it the F word, as if it's this mysterious thing. It took me a few months to realize it, but I've learned a lot, especially through Brian Cornelia, who's actually an alumni of the CSGF. I've learned a lot about why people call it the F word, but how the F word can stand for fun. And so moving on, I think around maybe February or so, I start picking up some work with a project called Open Catalyst. So still in kind of that chemistry domain, but as far as Open Catalyst, it more so uses AI models to do predictions on new materials, new catalysts for climate change. And so with this, I learned more about deep learning models, one called DomNet++, and I got more familiar with just the open source community, because a lot of the work we do is essentially merging our hardware and software stack, which is our products and our ROCm software, with other open source products such as PyTorch. And so in this, we started doing a lot of what's called ML perf work. And then what you saw before with CloudWorks, Brian Cornelia did me a huge favor by dropping off Berkeley GW at my doorstep, because I think he just, the F word again. But it's been a pretty nice journey going from these different applications to where you actually feel like but you gain ownership in these projects. Yes, you finish it and then you move on to, let's say, Open Catalyst or Berkeley GW, but you're always coming back to your old projects. Like, those are always your babies. And that's why you always document everything you're doing, because it's not just for you. We do a lot of publications to the open source community on this type of work. And then lately, I've been working on a project called Deep Learning Recommendation Model, which is the actual pain. I don't know who else does like heavy AI ML workloads, but could somebody please come up with a better way to get these data sets? Because with DLRM, I'm running around chasing like 400 gigabytes worth of code or worth of a data set, and nowhere to really put it. Because if you talk about like these ML perf workloads, I'm starting to realize it's not really just about having, faster hardware. Really more so it's about how data moves. For me, I'm starting to realize that even though we're trying to optimize these codes, we really have to always think about data movement in these situations, whether it be storage for data sets, but even when you're doing iterations amongst training or inference. And so lately, something that's been a bit different and way outside my wheelhouse is a project with Los Alamos, looking at the Legion programming runtime. And so in this is more so what's called porting of code, because on our systems, you usually have CPU code or you may have CUDA code. And a lot of times we're porting CPU or CUDA code to what's called HIP. And so people being as cool as they are, we just call it HIPification. And so we're just porting code over to our systems. And this is my first experience now with having like direct customer relations, which I'm seeing is very interesting, because you get cool people. However, when you realize that you're the one responsible for fixing someone's problem, they don't know what they're doing. You might not know what you're doing, but it's a nice challenge, especially when you get to really get familiar with certain people who head these projects. And so my current project with Los Alamos has been pretty cool, because I've never HIPified any code before in my life, but people allow you to take the opportunities that you want to see, and there's always people to help you as well. And so one of the great things that I really like about the team that I work with. Other than them being a little bit weird, a little bit goofy, I do like that the older people are a bit hip. I do enjoy that, especially Gina, she takes pride in making sure that our team is always in the community and doing some type of work. So during the internship, we did the Houston Food Bank. This past June, we went back and did the Houston Food Bank as well. But also, one fun thing that reminded me of A&M is that we did National STEM Day, where we helped a bunch of, I think 3 middle schools in Austin, Texas. We did essentially a computer build. We built 50 computers that day. And it just really reminded me of A&M, and I really love the fact that for me, it feels like a continuation of just enabling excellence and a better future for our communities, because that's what I've always seen in A&M. I've always seen it with the CSGF, with my journey and other people's journey. And I do love that I'm still in the place where we can enable that excellence for other people. And so I do just want to give a final recap and final thoughts to wrap everything up. With the new students, I've already said mainly, just when you see people, talk to them. If you think about them, reach out to them. Because I know for me, through my journey, there have been tough times. You have life, and then you have school, you have your program of study, and you have everything else. But one thing I've learned that this community is always there for you. And then sometimes you may have to step out your comfort zone and tap somebody on the shoulder. You may have to send that email. Especially Lindsay and Michelle, they're always there. So that's the great part about it. But I do love that literally I wouldn't be here today without the steering committee. Like people who came, like Dr. Howes and everyone who came after him, everyone on the steering committees for picking each one of us to come here. Because I know for sure when I first got here, me and my cohort were just like, when I got the call from Lindsay, I'm like, you sure you called the right person? Like, I don't really, everyone in my cohort said the same thing. Are you sure that this is for me? And so it's just exciting to see everybody grow over the years. It's exciting to see new faces. It's even exciting to still see kind of pieces in you, which you still have to build up. But when you come around everyone else, you're like, it's not really that big of a deal, or it's not a reflection on me. It's just more so something that you have to overcome. And it's better when you do it with a group of people who actually care about you. And so I do want to shout out my cohort. From 2017, I wish a lot of us would be able to come back next year, because like I said, this is my first time in 5 years. And I love Claire, Matthew, love Ben. And so I just want to end it with a quote: we as a community enable the excellence already within us. And so I just want everybody to remember that it's not about anyone pouring into you, but a lot of times when we do have this imposter syndrome, you already have the excellence in you. And just remember that, just really remember that, because it gets hard and there is life, but there's already something great in you, and that's why the steering committee picked everybody. So I thank you for your time.